Case 1. Schrödinger's cat. In 1935, physicist Erwin Schrödinger created what would become the most famous thought experiment in science, not to celebrate quantum mechanics, but to expose its fundamental absurdity. Picture this scenario: a cat sealed inside a steel box with a diabolical device. A Geiger counter monitors a single radioactive atom that has a 50% chance of decaying within an hour. If the atom decays, the counter triggers a hammer that shatters a flask of poison gas, killing the cat instantly. If the atom remains intact, the cat lives. Here's where reality breaks down. According to quantum mechanics, that radioactive atom exists in what scientists call superposition. It's simultaneously decayed and not decayed until the moment someone opens the box to observe it. This means the cat itself must exist in an impossible state, neither alive nor dead, but somehow both at the same time. The poor creature hovers in this nightmarish limbo, waiting for observation to collapse its quantum state into a definitive outcome. But this violates everything we understand about reality. Cats are either breathing or they're not. Hearts either beat or they've stopped. There's no middle ground in the world we experience, yet quantum theory insists this middle ground not only exists, but defines the fundamental nature of reality itself. The paradox reveals that our most successful scientific theory produces conclusions so bizarre they seem to mock common sense. What makes this truly disturbing is that quantum superposition isn't just theoretical speculation. Scientists have demonstrated it countless times with individual particles, atoms, and even small molecules. But where exactly does this quantum weirdness end and classical reality begin? At what point does a system become too large to exist in multiple states simultaneously? Nobody knows. And this uncertainty suggests that the boundary between the quantum and classical worlds might be far more fluid than we dare to imagine. Case 2. The twin paradox. Einstein's theory of relativity shattered humanity's most basic assumption about time itself. Consider two identical twins, Sarah and Emma. Sarah remains on Earth while Emma climbs aboard a spacecraft and accelerates to 90% the speed of light, journeying to a distant star and returning home. When Emma's ship lands, she discovers that decades have passed on Earth, while she experienced only a few years of travel. Sarah has aged into an elderly woman while Emma remains young. This isn't science fiction speculation. It's experimentally verified reality. Atomic clocks flown on high-speed aircraft consistently run slower than identical clocks remaining stationary. Particles called muons, which normally decay in microseconds, live dramatically longer when traveling at near-light speeds. Time dilation is as real as gravity, yet it demolishes our intuitive understanding of temporal flow. The paradox cuts deeper when we consider the implications. If time can stretch and compress based on motion, then simultaneity itself becomes meaningless. Events that appear to happen at the same time for one observer occur at different moments for another. The universe has no universal now, no cosmic clock ticking away the same seconds for everyone. Instead, time becomes personal, relative, and fundamentally disconnected from our everyday experience. This creates profound philosophical problems. If past, present, and future are merely relative concepts, does free will exist? Can we make choices about events that have already occurred in another reference frame? The twin paradox doesn't just challenge physics, it questions the very nature of existence and causality. Case 3. Zeno's paradoxes. 2,500 years ago, the Greek philosopher Zeno devised a series of logical puzzles that seemed to prove motion was impossible. His most famous involves Achilles racing a tortoise. If the tortoise gets a head start, Achilles must first reach the point where the tortoise began. But by the time he arrives there, the tortoise has moved farther ahead. Achilles must then reach this new position, but again the tortoise has advanced. This process continues infinitely, suggesting Achilles can never overtake the tortoise despite being faster. Another paradox claims that before traveling any distance, you must first travel half that distance. But before traveling half, you must travel a quarter. Before a quarter, an eighth. This division continues forever, implying that motion cannot even begin because there are infinite preliminary steps to complete. Mathematics eventually resolved these paradoxes using concepts like infinite series and limits. We now understand that infinite sequences can converge to finite values. But the resolution came at a cost, accepting that mathematical infinity corresponds to physical reality. This assumption remains deeply troubling because it suggests that space and time might be infinitely divisible, leading to other paradoxes about the nature of reality. Modern physics has revived Zeno's insights through the quantum Zeno effect. If you observe a quantum system frequently enough, you can actually freeze its evolution, preventing particles from changing state. The act of measurement itself becomes a prison, trapping quantum objects in their initial conditions. This suggests that Zeno's ancient intuitions about the relationship between observation and motion contain profound truths about the fundamental structure of reality. Case 4. The bootstrap paradox. Imagine a composer who travels back in time and encounters Beethoven as a young man. The time traveler plays Beethoven's Ninth Symphony, which hasn't been written yet. Inspired, young Beethoven transcribes the music and later publishes it as his own composition. But where did the symphony actually originate? The time traveler learned it from history, where Beethoven was credited as composer. Beethoven learned it from the time traveler. The music appears to exist without ever being created. This bootstrap paradox reveals how causality can form closed loops that seem to violate logical necessity. Information, objects, or even people can become self-causing, existing without any ultimate origin point. The universe somehow accommodates these causal circles, suggesting that our linear understanding of cause and effect might be fundamentally flawed. Consider another variant. A brilliant student receives a physics textbook from her future self, containing revolutionary discoveries. She studies the book, becomes a physicist, and eventually travels back to give the book to her younger self. The knowledge within those pages has no source. It wasn't discovered through research or inspiration. It simply exists in an eternal loop, passed from future to past and back again. These paradoxes become even more disturbing when we consider that they might not be merely theoretical. If time travel to the past is possible, the universe must somehow resolve these causal loops. The implications suggest that causality itself might be more flexible than we imagine, allowing effects to precede their causes under certain circumstances. The bootstrap paradox forces us to question whether everything must have a beginning. Perhaps some aspects of reality are eternal, cycling through time without ever being created or destroyed. This challenges our deepest assumptions about existence, suggesting that the universe might contain self-sustaining loops of information that transcend normal causality. Case 5. The observer effect. Quantum mechanics delivers its most unsettling revelation through the observer effect, a phenomenon that suggests reality itself might not exist in any definite form until something decides to look. When scientists fire individual photons at a barrier with two slits, something impossible happens. If no detector monitors which slit the photon passes through, it somehow travels through both simultaneously, creating an interference pattern that proves it took multiple paths. But the moment researchers place a detector to observe which slit the photon chooses, it behaves like a normal particle, selecting only one path and destroying the interference pattern completely. This isn't simply a measurement problem or technological limitation. The universe appears to fundamentally alter its behavior based on whether conscious observation occurs. The photon seems to know whether it's being watched, responding by either maintaining quantum superposition or collapsing into classical reality. What's truly disturbing is that this observation effect works backwards through time. Scientists can decide whether to measure a photon's path after it has already passed through the slits, yet this future decision still determines how the photon behaved in the past. The implications shatter our understanding of objective reality. If fundamental particles exist in undefined states until observation forces them to choose specific properties, then the universe might be far more dependent on consciousness than we ever imagined. Some interpretations suggest that reality remains perpetually unformed, a ghostly collection of possibilities that only crystallizes when minds interact with it. This raises the terrifying possibility that without conscious observers, the universe might not exist in any meaningful sense at all. Case 6. The Black Hole Information Paradox. Stephen Hawking discovered that black holes slowly evaporate by emitting radiation. But this revelation created physics' most devastating paradox. As matter falls into a black hole, it carries information about its quantum state, its history, its very identity. When the black hole eventually evaporates completely through Hawking radiation, that information appears to vanish forever, violating quantum mechanics' most sacred principle. Information can never be destroyed. This isn't merely an academic concern. If information can be eliminated from the universe, then the fundamental laws of physics contain an internal contradiction that threatens their entire foundation. Quantum mechanics demands that every particle interaction be reversible in principle. Even if you burn a book, the information within those pages still exists, scattered among the ash particles and heat radiation. But black holes seem to offer a cosmic paper shredder that permanently erases information from existence. The paradox becomes more disturbing when we consider what information actually represents. Every quantum state, every particle interaction, every moment of history leaves an informational signature in the universe's structure. If black holes can delete this information, they're not just destroying matter and energy, they're unwriting history itself, creating gaps in the universe's memory that can never be recovered or reconstructed. Recent attempts to resolve this paradox suggest even more unsettling possibilities. Some theories propose that information never actually enters the black hole, but remains encoded on its surface in a two-dimensional hologram. This would mean that our three-dimensional reality might itself be a projection, a shadow cast by information living on some distant boundary. Other solutions require abandoning either quantum mechanics or general relativity, forcing physicists to choose which fundamental theory to sacrifice. Case 7. Olbers's Paradox. Heinrich Olbers posed a deceptively simple question in 1823 that revealed a profound truth about cosmic history. If the universe were infinite, eternal, and uniformly filled with stars, then every line of sight from Earth should eventually terminate at a stellar surface. The night sky should blaze as bright as the sun's surface, turning darkness into perpetual day. Yet when we look up, we see mostly empty blackness punctuated by isolated points of light. This darkness initially seems trivial, but it contains devastating implications for our understanding of cosmic structure. An infinite, eternal universe filled with evenly distributed stars would create a night sky so brilliant it would make life impossible. The fact that we can see individual stars against a dark background proves that the universe cannot be infinite and eternal. Either space has boundaries, or time has a beginning, or the distribution of matter follows patterns we don't understand. The resolution came through Edwin Hubble's discovery that the universe is expanding and had a definite beginning in the Big Bang. The cosmic background radiation we detect represents the afterglow of creation itself, stretched and cooled by billions of years of expansion. But this solution raises even more disturbing questions about what existed before the Big Bang and what lies beyond the observable universe's boundaries. The paradox also reveals how profoundly our existence depends on cosmic history. If the universe were slightly older or structured differently, the night sky's blazing brightness would have prevented stars from forming planetary systems capable of supporting life. The darkness above our heads represents a delicate balance of cosmic parameters that allowed complexity, chemistry, and consciousness to emerge from primordial simplicity. Case 8. The Fermi Paradox. Enrico Fermi's casual lunch question in 1950 has evolved into cosmology's most troubling mystery. With billions of stars in our galaxy alone, and billions of galaxies in the observable universe, the probability of intelligent life emerging should approach certainty. Even if civilizations develop rarely, the sheer scale of space and time should produce countless technological societies. Yet when we scan the cosmos with our most sensitive instruments, we detect nothing but silence. This absence becomes increasingly disturbing as our understanding of planetary formation improves. We now know that Earth-like worlds orbit a significant fraction of stars, providing billions of potential cradles for life. If intelligence emerged on even a tiny percentage of these worlds, the galaxy should be teeming with artificial signals, megastructures, and signs of cosmic engineering. Instead, we find a universe that appears sterile and lifeless beyond our single, isolated planet. The possible explanations are uniformly terrifying. Perhaps intelligence inevitably destroys itself through warfare, environmental collapse, or technological catastrophe before achieving interstellar communication. Maybe advanced civilizations exist, but deliberately hide from younger species, enforcing a cosmic quarantine that keeps us isolated until we prove ourselves worthy of contact. Even worse, perhaps predatory civilizations systematically eliminate emerging intelligences, turning the galaxy into a hunting ground where survival depends on remaining silent and undetected. Another possibility suggests that consciousness itself might be far rarer than we assume. Perhaps the emergence of self-aware intelligence requires such an extraordinary confluence of factors that Earth represents a cosmic accident unlikely to be repeated anywhere else in the observable universe. This would make humanity not just rare, but potentially unique, carrying the sole flame of consciousness in an otherwise mindless cosmos. Case 9. Boltzmann Brains. Ludwig Boltzmann's statistical mechanics created an existential nightmare that undermines the very foundation of experience. In a universe governed by random thermal fluctuations, complex structures occasionally emerge spontaneously from chaos. Given infinite time, these fluctuations will eventually assemble any possible configuration of matter, including human brains complete with false memories of entire lifetimes. The mathematics are brutally clear. It requires far less energy and probability for quantum fluctuations to create a single disembodied brain with false memories than to generate an entire universe with consistent physical laws, stellar evolution, and billions of years of cosmic history. This means that, statistically, any conscious observer is more likely to be a Boltzmann brain with implanted memories than a real person living in an actual universe. This paradox destroys the reliability of all observations and experiences. If you're more likely to be a spontaneous brain fluctuation than a genuine human being, then your memories of childhood, your scientific knowledge, and even your understanding of this very paradox are probably false implants created by random chance. The universe you think you're observing might be an elaborate hallucination generated by a brain that formed accidentally in empty space and will dissolve back into chaos within moments. The implications cascade into complete epistemological collapse. Science depends on the assumption that observations correspond to real external phenomena. But if observers are more likely to be random brain fluctuations than genuine entities in a consistent universe, then all scientific knowledge becomes suspect. Every measurement, every experiment, every theory might be the product of false memories implanted in a temporary consciousness that exists only briefly before returning to thermal equilibrium. Case 10. The simulation argument. Philosopher Nick Bostrom constructed what might be the most psychologically devastating argument in modern philosophy, one that transforms every moment of experience into a potential illusion. His reasoning follows an inexorable logical chain that leads to a conclusion so disturbing it redefines the nature of existence itself. If any civilization develops sufficient computational power to run detailed simulations of their ancestors, and if they choose to run many such simulations, then the number of simulated beings would vastly outnumber real ones. The mathematics are terrifyingly simple. A single advanced civilization could run millions or billions of ancestor simulations, each populated with conscious beings who believe they're living in base reality. If even 1% of advanced civilizations choose to run such simulations, then for every real person who ever lived, there would be thousands or millions of simulated copies. This means that any conscious observer, including you at this very moment, is statistically more likely to be a simulated being than a genuine inhabitant of base reality. The argument becomes more disturbing when we consider technological trends. Computing power continues to expand exponentially while the cost of simulation decreases. If consciousness can arise from information processing, then sufficiently detailed simulations would produce genuine subjective experiences indistinguishable from reality. The beings inside these simulations would think, feel, and suffer exactly as real entities do, making their existence morally equivalent to biological life. What makes this particularly unsettling is that simulated beings would have no reliable way to detect their artificial nature. Their entire universe, including all physical laws, historical records, and sensory experiences, would be generated by the simulation. They might even develop their own theories about simulation arguments, never realizing that their philosophical discussions are themselves products of artificial computation. The paradox forces us to confront three equally troubling possibilities. Either advanced civilizations never develop the capability to run ancestor simulations, which would suggest technological development hits insurmountable barriers, or they develop the capability but choose never to use it, implying that ethical considerations or practical limitations prevent ancestor simulation. The third possibility is that we ourselves are almost certainly living inside a simulation right now. Each option carries profound implications for human purpose and meaning. If we're simulated beings, then our entire civilization might be nothing more than a historical recreation, a digital archaeology project conducted by our descendants or alien researchers. Our struggles, achievements, and relationships would remain subjectively real to us, but they would exist only as computational processes running on some inconceivably advanced computer. The simulation argument also raises disturbing questions about the nature of reality itself. If simulations can contain conscious beings, then consciousness becomes substrate independent, arising from patterns of information rather than biological neural networks. This suggests that the boundary between real and artificial experience might be meaningless, with consciousness emerging wherever sufficient computational complexity exists. Perhaps most terrifying is the possibility that our simulated universe could be terminated at any moment. The beings running our simulation might lose interest, run out of computational resources, or simply decide to end the project. From our perspective, such termination would be indistinguishable from universal annihilation, erasing every conscious being and every moment of history in an instant. Some interpretations suggest that simulated beings might even be able to influence their simulators through their actions. If the simulation is designed to study specific phenomena, then the simulated being's behavior becomes data that shapes the simulator's understanding. This creates a strange form of reverse causality, where artificial beings influence their creators through the very process of being observed. The argument also implies that reality might be layered infinitely. If we're in a simulation run by advanced beings, those beings might themselves be simulated by an even more advanced civilization. This creates an endless hierarchy of nested realities, with no way to determine which level represents true base reality. Each layer of simulation would be convinced of its own authenticity while remaining unaware of the greater computational framework containing it. Modern developments in artificial intelligence and virtual reality lend increasing credibility to the simulation hypothesis. As our own simulations become more sophisticated, we begin to glimpse how advanced civilizations might create entire universes populated with conscious beings. The gap between our current virtual worlds and fully realized simulated realities might be smaller than we imagine. The paradox ultimately forces us to question whether the distinction between real and simulated experience has any meaningful significance. If simulated consciousness is indistinguishable from biological consciousness, then the substrate supporting awareness becomes irrelevant. What matters is not whether we're made of atoms or algorithms, but whether we can think, feel, and experience subjective reality. Yet this philosophical comfort provides little solace when confronting the existential implications. If reality itself might be artificial, then every assumption about the nature of existence crumbles. The physical laws we've discovered, the history we've recorded, and the future we're building might all be nothing more than lines of code in some unimaginably vast computational system. The simulation argument represents more than a philosophical curiosity. It's a logical proof that our most basic assumptions about reality might be fundamentally wrong. We stand at the threshold of technological capabilities that could make us simulators ourselves, yet we cannot escape the possibility that we're already the simulated creations of minds far beyond our comprehension. These 10 paradoxes reveal the hidden contradictions that undermine our understanding of reality itself. From quantum cats existing in impossible states to civilizations vanishing into cosmic silence, from time flowing backwards to consciousness emerging from pure information, each paradox exposes how little we truly comprehend about the universe we inhabit. What unites these mysteries isn't their complexity, but their ability to shatter fundamental assumptions about existence. They prove that reality operates according to principles so alien to human intuition that they border on the absurd. Yet these paradoxes aren't merely philosophical exercises. They're windows into the deeper structure of reality, revealing that the universe is far stranger, more flexible, and more mysterious than our everyday experience suggests. Perhaps most disturbing of all is the possibility that these paradoxes aren't anomalies to be resolved, but fundamental features of reality that we must learn to accept. If consciousness, causality, time, and existence itself operate according to principles that violate logic and intuition, then the universe might be far more malleable and uncertain than we dare to imagine. The greatest paradox may be that minds capable of discovering these contradictions evolved within a reality that seems designed to hide its true nature. We've developed the intelligence to recognize the impossibility of our own existence, yet we continue to exist despite that impossibility. Perhaps that persistence in the face of logical contradiction is the most remarkable mystery of all. Each of these mysteries cuts deeper than mere scientific curiosity. They reveal fundamental cracks in the foundation of reality itself, suggesting that the universe operates according to principles so alien to human comprehension that they challenge the very possibility of understanding existence. What makes these paradoxes particularly unsettling is their persistence despite centuries of scientific advancement. We've split atoms, mapped the human genome, and sent probes to the edge of the solar system. Yet these basic contradictions remain as baffling today as when they were first discovered. They suggest that progress in understanding reality might be fundamentally limited, that there are aspects of existence so foreign to logic that they will forever resist explanation. The progression from Schrödinger's quantum cat to the simulation argument traces a disturbing path from physical impossibilities to existential uncertainties. We begin with particles behaving impossibly, advance through time flowing backwards and information vanishing, and arrive at the possibility that consciousness itself might be nothing more than computational processes running on some inconceivable machine. Perhaps most troubling is how these paradoxes interconnect, weaving a web of contradictions that encompasses every level of reality. Quantum mechanics undermines causality. Relativity destroys absolute time. Thermodynamics questions the nature of consciousness. And information theory suggests that existence itself might be artificial. Each paradox reinforces the others, creating a comprehensive assault on human understanding that leaves no aspect of experience untouched. The silence that greets our searches for extraterrestrial intelligence becomes more ominous when viewed alongside these other mysteries. If reality itself is fundamentally paradoxical, if consciousness is statistically more likely to be artificial than genuine, if information can vanish and causality can flow backwards, then perhaps the absence of alien civilizations isn't surprising. Perhaps any species that discovers these contradictions faces an existential crisis so profound that it either transcends physical reality entirely or simply ceases to exist in any recognizable form. These 10 paradoxes force us to confront the possibility that reality is not merely stranger than we imagine, but stranger than we can imagine. They suggest that the universe operates according to principles so fundamentally alien to human intuition that our evolved capacity for understanding might be insufficient for the task of genuine comprehension. We find ourselves in the position of ants trying to understand calculus, equipped with cognitive tools adequate for survival but hopelessly inadequate for true understanding. The implications extend beyond science into the realm of meaning and purpose. If consciousness might be artificial, if causality can form loops, if information can be destroyed, then what significance can human life and achievement possibly have? These paradoxes don't just challenge scientific theories. They undermine the very possibility of objective truth and meaningful existence. Yet perhaps there's a deeper message hidden within these contradictions. The fact that minds capable of recognizing these paradoxes could evolve within a reality that seems to violate logic suggests that the universe might be far more flexible and creative than our linear thinking allows. Rather than viewing these mysteries as problems to be solved, we might need to accept them as fundamental features of a reality that transcends human categories of understanding. The greatest paradox may be that we continue to seek answers despite knowing that the questions themselves might be meaningless. We persist in the search for truth, even when that search reveals the impossibility of truth. We maintain our sanity while contemplating ideas that should drive us mad. Perhaps this persistence in the face of ultimate uncertainty is humanity's greatest achievement, a defiant assertion of meaning in a universe that seems designed to frustrate all attempts at comprehension. These mysteries remind us that reality is not obligated to make sense to human minds. The universe predates our evolution by billions of years and will likely outlast our species by eons more. Our brief moment of consciousness represents an infinitesimal fraction of cosmic history, Yet somehow we've developed the audacity to believe we can understand the whole. These paradoxes humble that ambition while simultaneously celebrating the remarkable fact that such ambition could arise at all. In the end, these 10 scientific paradoxes serve as monuments to the limits of human understanding. They mark the boundaries beyond which our current conception of reality cannot venture. Yet they also represent invitations to transcend those boundaries, to develop new ways of thinking that might accommodate contradictions our present minds cannot resolve. They challenge us to imagine forms of consciousness and understanding so different from our own that they could embrace paradox as naturally as we embrace logic. The universe has kept these secrets for billions of years, revealing them only reluctantly to minds that evolved to navigate a much simpler reality. Perhaps the real mystery isn't why these paradoxes exist, but why the universe allowed creatures capable of discovering them to emerge at all. In a cosmos where logic fails and causality breaks down, the existence of minds that can recognize these failures might be the most paradoxical phenomenon of all. The journey through these 10 paradoxes reveals something profoundly unsettling about the nature of existence itself. We began with a simple cat trapped between life and death, progressed through time that refuses to flow uniformly, and arrived at the possibility that everything we experience might be nothing more than computational processes running on some inconceivable machine. Each mystery builds upon the last, weaving together a tapestry of contradictions that encompasses every aspect of reality we thought we understood. What emerges from this exploration isn't just a collection of scientific curiosities, but a systematic demolition of humanity's most fundamental assumptions about existence. These paradoxes don't merely challenge individual theories or concepts. They attack the very foundations of logic, causality, consciousness, and meaning itself. They suggest that the universe operates according to principles so alien to human intuition that our evolved capacity for understanding might be fundamentally inadequate for the task of genuine comprehension. Perhaps most disturbing is how these mysteries persist despite centuries of scientific advancement. We've mapped the human genome, split atoms, and sent probes to the edge of the solar system. Yet these basic contradictions remain as baffling today as when they were first discovered. They mark the boundaries beyond which our current conception of reality cannot venture, suggesting that progress in understanding existence itself might be fundamentally limited. The silence that greets our searches for extraterrestrial intelligence becomes more ominous when viewed alongside quantum cats existing in impossible states and information vanishing into cosmic voids. If reality itself is fundamentally paradoxical, if consciousness is statistically more likely to be artificial than genuine, then perhaps the absence of alien civilizations reflects something deeper and more troubling about the nature of existence than mere technological barriers or cosmic distances. These 10 scientific paradoxes force us to confront the possibility that reality is not merely stranger than we imagine, but stranger than we can imagine. They humble our ambition to understand the cosmos while simultaneously celebrating the remarkable fact that minds capable of recognizing these impossibilities could emerge at all. In a universe where logic fails and causality breaks down, perhaps the greatest paradox is that consciousness arose to witness its own impossibility.